Hello everyone, and welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. Today's seminar is called Teaching NGSS in K-5, Planning a Coherent Storyline. Our presenters today are Carla Zembel-Sol, Kathy Renfrew, and Mary Starr. My name is Christina Crawley, and I'm going to be moderating today's program. Now, before we get started with introducing our main presenters with the main show tonight, I am going to pass the baton over to Ted Willard, who is the Director of NGSS at NSTA, who is going to give us an introduction about the next generation science standards.
Thanks, Christina, and thanks everyone for being here. We're really pleased to have you folks and taking some time out of your summer to learn more and get ready for another school year. So I'm just going to touch really quickly here on some aspects of the standards. As you probably are aware, the standards were developed by 4 organizations: the National Academies of Science, Achieve, the American Association for the Advancement of Science, and my personal favorite, and I hope it's your personal favorite too, NSTA. The standards were developed in a 2-step process that first dealt with the framework for K-12 science education, then the standards themselves. And the standards are designed to have an effect on curriculum, instruction, assessment, pre-service education, and professional learning. So let's take a look at the framework itself and get a sense of it. It was completed in July of 2011. And if you have not looked at the framework, I'd strongly suggest you looking at it. There's no excuse. You can get a free PDF from National Academies Press, or you can buy a copy from NSTA Press. And the key element of the framework are the 3 dimensions: science and engineering practices, cross-cutting concepts, and disciplinary core ideas. And I'll take a moment and go through all 3 of those. Science practices are things like asking questions, developing and using models, analyzing and interpreting data, constructing explanations, designing solutions. These are the things that scientists do to learn more about the world, and these are things that students do to learn more about the world. The next piece in our 3 dimensions are the cross-cutting concepts: patterns, cause and effect, systems, structure and function. These are concepts that are not unique to any one discipline. They don't belong specifically in physics or chemistry or biology or geology, but they cut across, get it, all of the different core ideas. We also have disciplinary core ideas, the pieces like life science, physical science, earth and space science. And we also have added to that engineering and technology. Each of these disciplinary core ideas drills down into a finer grain of what pieces are. And so all of that is described in the framework. And the framework was then used by the people who developed the next generation science standards. So that work was done by a consortium or a grouping of 26 states, referred to as lead states. And so these 26 states each had a group of educators, dozens of educators who would review different drafts and provide feedback to the writers. And the writers as well were spread across the country. There were 41 of them, and half of them were classroom teachers at the time that they started doing the work. At this point in time, the standards have been adopted by 13 states and the District of Columbia. In addition, there are a number of states that have developed their own standards but use the framework as a guideline. But at this stage, we have 30%, 3 in 10 students in the United States live in a state that's adopted the standards. So let's take a quick look here at one of the performance expectations in the standards. And so this piece here, a performance expectation, this is a directive into what should be assessed at the end of instruction. It's not meant to tell you as a teacher what you have to do in your classroom. Your job is to use the full of your ability and your creativity to decide what activities your students should engage in to be ready to be assessed and evaluated on whether they can do what this performance expectation describes. But the performance expectation is designed in such a way that it really probes the three dimensions here. So we have construct an argument that plants and animals have internal and external structures that function to support survival, growth, behavior, and reproduction. So this idea of construct an argument is specifically described by this science and engineering practice. The core idea that plants and animals have internal and external structures, that is captured in the performance expectation. And then the idea that a system can be described in terms of the components and their interactions is captured here, with the idea of internal and external structures that function to support the different activities. And so this single performance expectation manages to incorporate all three of the dimensions in NGSS. And with that background, I will pass you off to our wonderful presenters tonight. Thank you very much.
Thanks, Ted, and welcome everybody. We're glad to have you with us for the third and final webinar in our series for summer on teaching NGSS in K-5. The focus tonight is on planning a coherent content storyline, and that actually came out of a series that the three of us did in the fall and the winter on K-5 NGSS. We went grade level by grade level, and those are available in the archives if you're interested after tonight's presentation, if you're joining us for the first time. My name is Carla Zembelfall, and I'm a professor at Penn State, where I work with pre-service and in-service teachers as they learn to support students in engaging in scientific discourse and practices. This year I was honored by an NSTA fellow, as an NSTA fellow, which I'm really proud of. And I'm also the co-author of What's Your Evidence? Engaging K-5 Students in Constructing Explanations in Science. And tonight I'm here with my good friends and colleagues, Mary Starr, Kathy Renfrew, and of course Ted. Hey Ted. Anyhow, I'm going to pass it off to Mary and Kathy, and they will introduce themselves and we'll get started. Sorry about that.
That's okay. Sort of freaked me out. Hi, I'm Mary Starr, and I'm sitting in beautiful Michigan this evening, where I am the Executive Director of the Michigan Math and Science Centers Network, and also a middle school science curriculum author. And it has been, since we're finishing up our series, I'm going to say that it has been an absolute pleasure to work with several hundred teachers who have joined us on this whirlwind 3-week adventure through NGSS in K-5, and also with my colleagues from NSTA and Carla and Kathy. It's been a little crazy on our end, making sure that we're very prepared for each one of these webinars, but it's also been a total pleasure to share what we know and to hear from the teachers, hear from you what you're thinking about and educating us. So thank you very much, and I'll turn it over to Kathy.
Hi, my name's Kathy Renfrew, and you know, Mary, I'm in beautiful Vermont, and I'm actually sitting at the Snowflake Mountain Resort and Spa tonight. So I think we've got a little bit of a competition going there. But anyway, my name, excuse me, I'm the K-5 Science Coordinator for the Agency of Education in Vermont. I'm a NGSS curator. I'm kind of an NGSS junkie. I think NSTA is awesome in all of the possibilities and resources and opportunities that they provide. And I guess I want to ditto what Mary said about this has been amazing in terms of my own professional learning, just by being able to talk with you and then go back and listen to the webinars again and read the chats and think about, you know, everything that's been said. So I'm looking forward to this evening, and I hope you are too. And with that, I'm going to hand it right back to Carla.
Thanks, Kathy. I had a little trigger finger there, so You probably saw this slide, but now that you know a little bit about us and what we're doing, we'd like you to tell us about yourself and how much time you are able to spend teaching science in a typical week. So if you're a classroom teacher, and it looked like we had a fair number of you with us tonight, if you could use the clip art to reflect the amount of time you are able to spend in a week. If you're an administrator or someone who works with teachers, tell us about elementary classrooms in your district. Well, I'm actually really impressed. A lot of you have the luxury of you must be doing science almost every day to be getting in the amount of time that we're seeing reflected in this poll. And for those of you who don't have a lot of time to teach science, what we're hoping is that the webinar that we're doing today will give you some ideas about how to integrate teaching science into the rest of your curriculum as well. So we'll ask you at the end if we actually accomplished that. So thank you for doing that. We're going to move on. I'm going to skip over this poll. So for our webinar tonight, we have a few goals, but the focus is on Coherent Content Storyline as a planning tool that can be used to support three-dimensional learning, which Mary's going to talk about in just a moment. And as always, we'll share an example from the elementary classroom to illustrate how we use Coherent Content Storyline with teachers, with the teachers that we work with. As always, we ask for your participation in a productive way. The goal is to foster a community of professional learning, so share your ideas and resources as relevant to the presentation with our colleagues in the chat window box all throughout the presentation. It's not going to bother us if you're typing about the presentation and your ideas. Also, it's helpful for us as presenters to know that you're actually out there and what you're thinking about. So we try, the benefit of having three of us working on this, and actually more, is that we can capture your questions and hopefully come back to those as we move along. So the next generation science standards challenge all of us, and I think Kathy talked about her own professional learning through this, as did Mary. Even those of us who are very experienced with teaching and learning science in this way, it has been a challenge to think about and to consider the new framework for K-12 science education, which puts forth a new vision for student learning. And so there are several shifts, and these aren't the same shifts that are recorded or put forth in the framework, but these are shifts that Mary, Kathy, and I think are very important if you are really serious about working with NGSS in your classroom. And the first set is here, and that has to do with a shift to three-dimensional learning. We're not just talking about a focus on fact after fact after fact, but big ideas, core ideas, what are those? And that needs to be intertwined. We know from the research that learning scientific and engineering practices alongside of those core ideas are important. It helps students understand both better. So it's no longer the scientific method and just process skills. And tonight we're really focused on these discrete learning experiences rather than that, moving to more connected, coherent experiences, and the cross-cutting concepts can help us do that. The second big shift has to do with going from topics to explaining phenomena. And when you make this shift and you begin focusing on phenomena and driving questions, it really situates the investigation and creates a purpose for students to learn, which is really important as you move to adoption of NGSS. And really, even if you're not from an adopting state or district, I saw Ted writing that some people have done this quietly, that it's still important. We know that these things are very helpful and enhance student learning. So this is a way to improve on science teaching, whether you're adopting NGSS or not. The third shift that we're talking about is one that involves us as teachers, moving from teacher telling to having rich classroom discourse interactions. So if you're interested, our webinar last week focused specifically on making thinking visible and not just eliciting students' ideas, but leveraging student ideas to move lessons forward. So that was archived and it's on Classroom Discourse and that's available to you. But that is a very important part of the learning. Kids are doing the constructing and the meaning making with explanations of scientific explanations for phenomena. It's not just the teacher telling what the explanation is. And finally, the fourth shift that we like to focus on is one that moves us away from activity to giving priority to evidence and explanation. And again, this is another place where you'll see us emphasizing tonight the development of a coherent sequence of learning opportunities based on big ideas, not just on the activities that might be in a binder that was given to us 10 years ago by someone in our building. So we're really trying to move forward with this one. So throughout our time together tonight, we're going to be coming back to this particular visual. We want you to recognize that our goal is children's sense-making, meaning-making in science, and that we focus on, and let me get a little tool to help me here, we tend to focus our work on constructing explanations from evidence. It's not the only place that you can focus, but that is what we do, and we do it because there's a powerful framework for helping you construct explanations and your students. That's CER. Mary will talk about three-dimensional learning. Kathy, if we can get there tonight, we'll talk about discourse-rich opportunities in classrooms that are related to constructing explanations. And they're also useful instructional and assessment strategies. So we find this to be pretty useful. Tonight we'll be looking into a classroom. It's Kimber Hershberger's classroom. She's not able to be with us, but she's a third grade teacher locally and an outstanding collaborator, and she was actually the co-author of the What's Your Evidence book with me and with Kate McNeil. So last academic year in Kimber's classroom, she kicked off the beginning of the year with an adaptations unit, and she used when we start talking about what's your phenomena, and in fact, I've often thought maybe we should go back and rename the book What's Your Phenomena instead of What's Your Evidence, because you need a really rich phenomenon or the rest kind of falls apart. But what she did for adaptations is that she brought in some Madagascar hissing cockroaches. I don't know if you're familiar with this. Some people are a little put off by them, but kids find them absolutely fascinating. And when they observe them closely, they start to notice some really interesting adaptations. And when they try to handle them, they make a distinct hissing sound, which is a protective adaptation. They actually blow air through their spiracles on their body so that the predator that's trying to pick them up will drop them, and they will have a chance to blend in or get away. So kids are absolutely fascinating. Yes, they're giant. If you saw Men in Black, the movie, at the end, the guys squishing cockroaches, those aren't real U.S. cockroaches that we would typically find here. Those are Madagascar hissing cockroaches. That's just an aside. So, but anyhow, once kids start looking at these closely, the questions start pouring out. They want to know what the adaptations are, how does it help the organism survive, where did they come from, how and why do they change over time. And this is inevitably related to what Kimber wants to teach about, but it comes from the students and their observations. So tonight we're going to do something a little bit different. We're actually going to start at the end. Usually we build you up to some samples of student work and teaching, but tonight I'm going to start with some samples of student work. This is work that the children that you were just looking at were doing. These are, again, 8- and 9-year-old children in the 3rd grade at the end of the first unit of the academic year. And so one of the big, it's not the ultimate question for the unit, but one of the big questions that the kids are trying to answer is how do changes in a population occur over time? And so their claim that they start to come up with is that variations in traits are responsible for this. And the ones with the traits have the offspring that are helpful traits, and over time the population changes to have those helpful adaptations. And they're using evidence from some of their investigations to back that up. So I have to say that at least I have been impressed with kids that can write explanations like this in science. And so the question becomes, how did Kimber get them there? What did she have to do? And so one of the things that Kimber and I use both in her teaching, in my teaching at the university, and we both co-teach methods courses, is we use the idea of a coherent science content storyline as a guide. And one of the things that you need to know about storylines is that at this point in time, people are talking about storylines in lots of different ways. I just saw a question about the kids. They're 8 and 9 years old in the beginning of the year in a 3rd grade class. And they were writing about, I'll show you in a minute, ultimately they're trying to talk about the cockroaches, but they're talking about a population of simulated organisms that we'll share. But back to the storyline. So in NGSS on the Achieve website, you will see something called storylines that looks more like a paragraph about what kids should be able to do and what you should be investigating. That is different than what we're talking about as a storyline. Brian Reiser and his group have a version of storyline that's really nice and integrates the phenomena. But what we're doing tonight is it comes from the work of Kathy Roth, and we'll come back to the specifics of a storyline in just a moment. But at first I want to tell you where it came from because it wasn't just something that Kathy made up. She was the lead researcher on the TIMSS video study of 8th grade students back in 1999. It actually took quite a bit of time. This is an international study. And what they did was they did a random sample of 100 8th grade science lessons in each country that they were studying, and all the video was recorded in one school year. So they weren't just looking at the curriculum, they weren't just looking at textbooks or student scores on tests. They were looking at actual science teaching in classrooms as well as the student questionnaires. And the big question that they were after was, what opportunities did the lesson provide for students to learn science, to really learn the science? And they looked at teacher actions, they looked at student actions, and they looked at where the science content showed up within the lesson, and as much as possible took into consideration the cultural context that they were dealing with, since they were looking at multiple countries, schools in multiple countries. And the findings, maybe you're surprised by this, maybe you're not. I think the good news is that U.S. students engaged in a variety of types of activities. They were able to follow directions and carry out those activities, but they were not asked to think, here's the problem, not asked to think or reason about the underlying science concepts. And so if you look at the U.S. column here, the gray at the top is doing an activity with no conceptual links. And that's really concerning, and clearly we're doing that more in U.S. classrooms than in other places. The next bar down is with minimal links to the concepts, and then finally with strong links to the concepts. So this is interesting, and so what they did was to pull out of that what they were calling a storyline. And the way that they frame storyline is that they consist of carefully chosen and sequenced science ideas that build on one another to illustrate a bigger picture. And again, these are the pieces. So there's a main learning goal and a question that's related to that main learning goal. So there's a big idea and a question about it. The activities that you do match up with that, as well as the representation. And here's a big one, that those ideas are linked to other content ideas, and that they develop over time in some sort of sequence appropriately. So we use this to start to think about what kind of tools would be most helpful. They also went ahead and studied this. There was a project, the Science Teachers Learning from Lesson Analysis, and what they really found is that there are 3 content storyline strategies that really significantly had an impact on student learning. That had to do with linking the science content and ideas to activities, content ideas to other science ideas, and the representations match the learning goal. So that has a lot to do with connections and with sequencing. So back to this, tonight we thought we would put that lens of a content storyline on putting together a coherent, using content storyline, coherent content storyline, and foregrounding that as we look at the kinds of ways that we go about helping students construct explanations from evidence. And so with that, Mary is going to focus on 3D learning as a way to start us with a focus on science ideas.
Okay, thanks, Carla. Ted earlier talked about three-dimensional learning as a key component of the framework for K-12 science education and the next generation science standards. And my job is to provide an overview that's both general and then specific to the ideas of the content that Kimber was teaching. So we know that there's three dimensions: science and engineering practices, disciplinary core ideas, and cross-cutting concepts. And we've been using for these three webinars this quilt analogy that we've borrowed from Arthur Eisencraft. And when we think about the quilt, we realize that there's these three pieces of the quilt that all come together in order to do the job of the quilt. And in our case, these three dimensions of science learning that help support students' abilities to explore, examine, and explain science phenomenon. So we know that from the next generation science standards, those three dimensions that are put in the performance expectations are assessment outcomes. Ted mentioned that earlier, so we need to keep focused on the idea that these are long-term assessment outcomes. And as we move through the storyline, we're going to see differences in the lesson level expectations. In Kimber's instruction that we're going to see today, we've been focused on the disciplinary core ideas around life science, inheritance of traits, and variation of traits. So when Kimber was having the students investigate, explore the Madagascar hissing cockroaches, she knew that these were the disciplinary core ideas that she wanted to focus on in her instruction. So in building the performance expectations in NGSS related to this, we know that each one of those performance expectations has one disciplinary core idea, cross-cutting concept, and science and engineering practice. So those are the pieces in each performance expectations that build that three-dimensionality. One of the dimensions from each of the, one dimension from each of these. All right, so here's a performance expectation that Kimber might be using. The third grade is indicated, and then the life science and the core idea regarding evidence that plants and animals have traits, and that there's some variation in these traits is a cross-cutting concept. The science and engineering practice in this particular performance expectation is around analyzing and interpreting data. So it's important that you notice that these are the three dimensions in this performance expectation. As we move on, you might find that these are not the dimensions that you use in instruction. Right? The cross-cutting concepts in particular, we thought we would focus a good amount of time in each of these three webinars this summer on the cross-cutting concepts. So the one for this performance expectation was around patterns. The cross-cutting concepts provide students with a lens on within the instruction. So when they're thinking about explaining phenomenon, the lens they would use in order to meet these performance expectations is patterns. And it really varies when you think about students changing lenses and making an explanation with the lens of patterns versus perhaps a lens of cause and effect. That the way that they would explore and the way that they would explain a phenomenon will vary depending on the cross-cutting concept that we're focusing on. The science and engineering practice is analyzing and interpreting data. And this is going back to that performance expectation. And what we know is that in the science and engineering practices, even though the one identified in the PE is analyzing and interpreting data, we also know that all of them end up being used by students in critical ways in order to move towards developing explanations and engaging in argument from evidence. So the interactiveness of the science and engineering practices is really a powerful piece of the 3 dimensions of science learning. So then the performance expectations provide us the outcome measures, the assessment measures. In instructional goals, however, it's really important, and I'm working with the teachers that I'm engaged with around thinking about the instruction with 3 dimensions also. So it's not just the performance expectations from NGSS, but also how do we structure instructional goals on a lesson-to-lesson basis. So in our case, our 3-dimensional learning phenomenon is about traits and offspring. And so when Kimber is developing the coherent content storyline, she's focused on exploring, examining, and explaining this phenomenon, right? So how do students get there? It means that we need to focus and pay particular attention to the disciplinary core ideas, and then keeping in mind the other 2 dimensions, cross-cutting concepts and science and engineering practices. So it could be true that in instruction, the core idea stays the same, but the disciplinary core, or the cross-cutting concept could be patterns, and science and engineering practice might be about developing and using a model. So somewhere in the coherent content storyline that Kimber develops, she might have an expectation where the dimensions are different from the performance expectation. Still, the focus is on moving towards using the science and engineering practices towards developing explanations and engaging in argument from evidence. So Kimber, I saw a ton of comments about these hissing cockroaches, and Kimber picked an amazing phenomenon for the students to explore. She knows that this is a phenomenon that kids can engage in and provides them access to understanding all those core ideas, to using all those core ideas around the hissing cockroaches. And a lot of conversations have been happening about what is phenomena. And Carla, Kathy, and I are really interested in these conversations because sometimes we focus on the big stuff, like the stuff that goes bam, and kids are always asking, when are we going to get to cut something open? Thinking that science class is all about those really huge, phenomenal experiences. What we know, though, about students, especially K-5, is that everyday stuff is phenomenon. Everyday stuff like are cockroaches, how are cockroaches different from each other and similar to each other? Or how does my body work? Or why do birds migrate from one place to another? These things are also phenomenon, and they're phenomenal. And kids have real interest in exploring and understanding the everyday world in that way. So we wanted to just make sure that we put out there, things don't always have to explode. There's a lot of things that kids are naturally interested in. So around this idea of traits and diversity and offspring, we thought we would ask you, what phenomenon would you use or have you used to engage students in thinking about and being able to use these core ideas to explain? So if you could use the text box to add some of those phenomena to, that'd be a great way to share with each other. Right, so I see chicks and mealworms. Those are really common organisms to use. Exploring chicks, watching them hatch, kittens, many different kinds of organisms that you can either watch or use video, or insects are awesome. Plants are great. They just take a little bit more time, right, than a lot of insects. So if you have any other phenomenon that you want to add to our growing list, that would be great. Just keep them coming. And I think that Kathy is going to move on now and focus a little bit more on prior knowledge. Kathy?
Mary. So one of the things that, and this goes back a little bit to last week when we were talking about formative assessment too, but it's really important that we remember that when kids come to us, they don't come to us as with blank slates. They come to us with many different levels of science understandings, and some of those science understandings are everyday understandings, which quite often are different from the school science understanding that we would like them to move forward with. So one of the things that, again, it's really important for us to know is what that understanding is. So what we want you to do is to, when you look at this chart, can you use your clip art and show us some of the ways that you assess students' prior knowledge? Yes, Bill?
Okay, try that again. It looked like it was clicked off. Go for it.
Oh, it's looking much better. I'm feeling much better.
My fault.
Okay. I don't want to spend a lot of time here, but it's obvious that all of you are doing lots of things to get at the students' prior knowledge, and that is just so important because, like I said, they don't come to us as blank slates, and we need to think about what they tell us with their prior knowledge. So what are some of the ways? I've talked a little bit about this. I'm not going to spend a lot of time here, but I want to share a couple of the ways that that I use to get prior knowledge, to get students prior knowledge. And one of the big ones is, for me, is really depending a lot on Paige Keeley's probes. She has done an amazing amount of work and research around this idea of finding out what students are thinking. So in tonight's consideration of tonight's, here's one probe that would work with what we're talking about tonight. And it's basically just to find out what students understand about the topic of adaptation. So I don't know if you can see this, but quickly, these friends were arguing about what would happen if the rabbits from the southern climate moved to the cold climate. And one person says, okay, I think they're all going to try to change to adapt. And somebody else says, I think most of the rabbits will try to change. And Phoebe says, I think few or none of the rabbits will try to change. Well, Phoebe's right, because as we know, rabbits can't try to change. They aren't going to choose to change, and they aren't going to change over their lifetime. But again, it's just one way of looking at this information. Another probe that will do the same thing to give you an idea of what students are thinking is it emphasizes, again, that the individual organism cannot intentionally adapt to a change in their lifetimes. Okay, a resource that's so important. We've talked about it before. I just can't emphasize enough. Ted talked about it. Mary and Carla have both mentioned it in different ways, but it's like my Bible. And again, free or from NSTA Press. Another place to get information, content knowledge, is the web seminar archives. There happens to be one that was done last year on heredity, inheritance, and variation of traits. And as an elementary classroom educator, I know there was a time when there was no way, and I still don't have all of the knowledge that I would need to comfortably teach something without going back and doing some content review for myself. And I think we just need to remember to use the resources. Now, just again thinking about that assessing prior knowledge, what are the benefits for teaching? Well, the benefits for teaching is we really begin to figure out what's going on in the classroom. We see ideas in places where we can leverage points in students' current understandings, and we can really get their productive ideas flowing. We can find out what's happened in students' lives and maybe create learning experiences that provide all students with the same learning experience so that they begin to move forward together. And we, again, remember that students bring with them their culture. Again, they're not blank slates. So what's in it for the students? Well, it signals to the students, the thing that I think is really important here is that their ideas are valued and they're honored. And it lets them hear everybody's ideas. They can listen to them carefully, they can hear them. They can evaluate those ideas and say, that works. Maybe I should think about this a little bit differently, or no, I disagree with that. What do I want to say to disagree with that respectfully? But again, there are benefits. Assessing prior knowledge there are benefits for the teacher as the instructor and benefits for the student as the learner. Some more content support. I went to the ebook and found this heredity and variation. NSTA has lots of resources to support us elementary educators and other educators as when we're looking for content information. Web seminar archives one more time. The Learning Center, one of my favorite places to go. And I'm going to give it back to Carla.
Thanks, Kathy. So you've looked at the big idea that Kimber's going to be dealing with. We're back to this just to remind you that our focus is on constructing explanations from evidence, and while we're also simultaneously considering 3D learning. And I'm going to be introducing the claims evidence reasoning framework as one of several different frameworks that can help you have this kind of a focus, as well as instructional strategies like the coherent content storyline and planning. So also just a really quick reminder of the features of a content storyline, very important. You have big ideas, the questions are matched to them, you start with the big ideas, and you connect content over time and through the use of sorry, Kathy, I think you still have your microphone on.
Oh, sorry.
So we use the activities, no, that's okay. We use the activities to be able to connect and help us get to the evidence that we need to construct explanations. So let's take a look at this. For those of you who may not be familiar with this, the claims evidence reasoning framework, the students and the teacher in the video that you're going to see, so Kimber and her class, are using claims evidence reasoning as the way that they build explanations. And so I would hope that you see evidence of that. I ask you to pay attention and look for evidence of that. Here is another view, and again, with attention to the fact that the focus, you need these pieces. Actually, this framework suggests that these are the pieces that you have to have in order for it to count as an evidence-based explanation. You're engaged with that phenomena, the questions that you're investigating really require you to understand the phenomena and be able to explain it. That explanation comes in the form of a series of claims that are backed up by evidence. And then I'll say a little bit more about scientific reasoning in a moment, because I know that I've heard that a number of people are struggling with that. So back over here, we're looking at the core idea that Mary shared about inheritance and variation in traits. So as we suggested, you as the teacher really need to understand this before you set about working on a content storyline for your kids. And that's why Kathy shared the resources with you previously to build your own content understanding, and you need to be able to assess the prior knowledge of your children in your classroom. And that's what she suggested, that Paige Keeley's probes are a really good way to do that, and I would agree. So Kimber also assesses students' prior knowledge. I saw in the chat box some people were talking about talk as a way to assess prior knowledge, and Kimber certainly does that. She uses something called a clues chart, and we did that in a prior, we talked about this particular strategy in a prior webinar. But this column right here is not what we know, but it's what we think we know at the beginning. It's where students might write a prediction or initial explanation for the phenomena, and it gets recorded and it's made public so that they can revisit that over time. It also helps the teacher understand where the kids are. So after that, she also, not after that, but at the same time she's doing that, she's also having kids use notebooks. And so notebooking in the classroom is a big deal for Kimber. In this particular unit, the kids call these their naturalist notebooks. And it's where they collected data, wrote their ideas, built explanations, and they are constantly using those notebooks as part of their learning. So keep in mind when you see this video in just a moment that the claim that Kimber is working towards is one about variation in traits. So they've got this population and they're trying to look at them to try and figure out what's going on with the traits in a population. And so here's where we'll start talking about storyline. In this particular storyline, Kimber actually uses, when she writes her own notes for the unit, because we are not in an adopting state and the local school district is not yet using the NGSS. But she uses it as a teacher to help her think about what she's going to do, and she layers on claim, evidence, reasoning in relation to the question that she's working on with kids. And so this is important because it gives her a chance to plan and rehearse what kinds of things kids might be able to say and the kind of reasoning that they're going to need to be able to say it and to understand that. So before this lesson, you have to know that kids already know something about insects and their common characteristics, and they know how insects fit into the larger grouping of arthropods. They were getting ready for something that is a really big deal here in State College, which is the Great Insect Fair. The kids actually identified some insects with some really interesting adaptations, and they build them in their natural habitat, and she had them do some writing in Comic Life about those before we ever get to this particular lesson. So they're pretty familiar with what counts as an insect. But this will give you a little bit of an idea. This highlighted piece right here is from the lesson that you're going to see today on the video. But things happened before that, and she tries to always build that in to a CER sequence too, even though in some cases the kids aren't interacting directly with particular phenomena, but here they happen to be. So claim, evidence, reasoning, again, is a way to plan for her to think about what comes before, what do kids need to know in order to be able to do this component, and then if we're moving on, we think about here's this part that we're going to look at again today and it's highlighted, but after that, she did additional investigations that continue to build towards where do these traits come from, how do they help a population of individuals survive in a particular environment, and then the survival for that particular species. So this is sort of, when we're talking about content storyline as a tool for planning, what you should be seeing here is that she's got a big idea which comes out in the claim. She's got to craft that to the phenomena in the question, and then where are the kids going to get the evidence? What evidence can they use to back that up? I actually know a lot of teachers wander around with this when they build it. They carry it with them during the lesson. It's comforting in some way to know what the roadmap is and where you're going, and to keep the focus on those big ideas. So we're going to get to the video now. We're doing variations of traits within a species. What's happened here is that the kids have closely observed their cockroaches, and each group of kids got a particular cockroach. They were all taken from a culture of cockroaches that gets kept in the classroom. They're all about at the same life cycle stage, so when they start talking about size being different, it can't be attributed to age. So the classroom that we work in, or the school district that we're in, is in central rural Pennsylvania. I mentioned this before, but I'll remind you that the lesson is from the first science unit of the year, and that was last academic year. There are 22 kids in the classroom. 3 of them are English as a second language students. They're designated in that way, and we have 2 students with IEPs in this group. And this is a very knowledgeable and experienced teacher. As I mentioned, Kimber's co-author for What's Your Evidence, and we've edited this video down from multiple lengthy lessons. The last thing I always say before showing a video of classroom practice is that virtual Vaseline wall, that's awesome. Yes, we have to coat the insides of the tanks with Vaseline. Somebody knows there are cockroaches out there. That's kind of fun. Otherwise, they will escape into your classroom. Kimber is known for lots of different critters escaping in her school, so it's kind of a running joke among her colleagues that if they find something unusual wandering the halls of their classroom, that they check with Kimber first to make sure that it didn't come from another source, but she's usually the culprit. So back to learning from practice together. The final point here is that without teachers who are willing to let us come into their classrooms and observe and learn from practice, then we will never be able to move forward as a profession and as a group. So it takes incredible courage and tolerance. I mean, we have cameras in their faces and mics hanging from the ceiling, and it is a distraction to have a video crew in your classroom. And so high praise to anybody who lets us in their classroom, and a huge thank you. And so please keep that in mind as you're making comments about Kimber's teaching. So we're going to have Christina push this out to you in just a second. But as you're watching this, knowing that Kimber is using claim evidence reasoning, I really want you to be thinking about how Kimber helps the students construct a claim from evidence. And this video will take about 5 minutes. I'm going to warn you in advance of watching the video that the volume will be louder than whatever you're set to. So have your finger on the volume and be ready to adjust. I don't want anybody to experience any hearing loss tonight. So Christina, can you help us get this started?
Sure. So I will go ahead and push this to you. You don't have to do anything. It's just going to open up in your browser, whether that's Chrome or Firefox or Internet Explorer. But before I do that, when you've had a chance to listen to the whole or watch the whole video, when you come back to Blackboard, where the poll button used to be, where it was A, B, C, D, E, it's now a check mark. It's a green yes or a red no. So when you come back in the room, if you could just give us a green check, then I'll be able to, we'll be able to know who's back and we can get started again. Okay, so here we go.
So I'm aware that some people got to the video a little bit late or had issues with that, but we're going to come back together in about a minute. So if you can, if you're back in the room already, if you can start typing in the chat window about how does Kimber help students construct a claim from evidence. And the link is available if you'd like to go back and watch the video. I'll ask that Christina or someone, one of the moderators, put the link back up.
I think that the question got missed by a few people. It kind of broke up there.
All right, let me try that again. You should be, if you're back, responding in the chat window to how does Kimber help students construct a claim from evidence? Great, so I see that you're noticing that she returned to the main question at the end of observations. She's introducing scientific terminology as needed, or actually reminding them of some scientific terminology that they knew previously. They're writing notes. She's encouraging them to look back into their science notebooks. The students have the opportunity to collect data. All of these things are very, very important. And one of the things that I'm noticing that people are cueing in on is this notion of observation. And that's really, really important for this kind of work. So let me give you a closer look at what kids were actually working on. So we had this question about, can you find your cockroach? They had observed them closely, and they know their cockroach really well. So at first blush, cockroaches look really similar. Madagascar hissing cockroaches look really similar to one another. But they looked closely, and then they looked at other groups, and what they were trying to do is find out if there was enough individual difference to be able to identify their own cockroach, and they were able to do that. And so the explanation that they write for this, take a second and look at this. Can you find the claim, evidence, and reasoning in this piece of student writing? And keep in mind, this is the first unit of the year, and the idea of claim, evidence, reasoning has just been introduced to students. So let's take a look at this. What we see here in the student writing is that they're making a claim. Do cockroaches have individual differences? Yes, because we were able to identify our team's cockroach. And then you can see that they start using the language of evidence. Our evidence was that our cockroach was a different color and size. Okay, and then they had their specific data there to back it up. And then finally the reasoning, the differences are because they inherited genes from their parents that gave them different color patterns. And so you may be saying, and I thought I saw someone say earlier that that their kids might not know what these words mean. And actually, when people are beginning to use reasoning, which is the underline in green, one of the things that we suggest is that you introduce it as needed. And it usually comes from sources other than the direct investigation that kids are involved in. So for example, the kids in their naturalist notebooks have been keeping, since their bug building days, a glossary. And they, when they put words in the glossary, they agree on how they're going to do this. And so what they were doing is looking up at other resources, texts, online resources, and talking about the way that they were going to use those terms, those science ideas, to make their explanations better. So just in case you're wondering where that's coming from, it's sort of an on-demand piece. And Kimber is really good at moving back and forth between talking and writing, and she models quite a bit for students. What is a claim? How are we going to talk about claim? You have to back up your claim with evidence. You can't just say that you think this is going to happen. You might be able to do that in your everyday life, but you need to back that up with evidence when you're having a science talk. And so she's modeling constantly. And here she is working with a small group. So she's back and forth modeling with the whole group previously and with a small group. These kids are actually doing what we fondly refer to as the dot lab here when I teach with undergraduate non-science majors. Most people do this as a camouflage activity, and so what would happen is that the kids put different colored dots down. The dots are just a variation of a trait in a species that's all one population of dots, or dot beetles, or whatever they're going to call them. And most people do this as camouflage, so the kids turn around and turn back and then pick the ones that they see first. The issue with that is that you don't see change in time. What you see is that you're able to pick off the ones that stand out the most. So it's a great illustration for camouflage, but it doesn't show you what happens if the ones that are eaten don't reproduce and the ones that were left behind, the survivors, reproduce, and what happens generation after generation. And what you can begin to see is that the population shifts from having equal numbers of each color of dot beetle to having certain ones, the ones that were surviving and reproducing, actually having more. And so then we do crazy things like introduce a drought or change the environment in some way to add a new pressure. But again, the third graders were perfectly able to get this idea that to go beyond one generation of getting eaten to what happens with the survivors in the next generation. The ones that have that color that help them survive will have more offspring, and the population will shift in that direction. So when we get back to this question that she was really after with the kids, how do changes in population occur over time? This is a slide that I showed at the very beginning. Variations in traits help some members of a species to survive and have offspring with the helpful traits. Over time, the population changes to have the helpful adaptations. And then you can see how they were drawing on that last piece here for evidence, but really it was all the pieces prior to that that helped them get to a way to talk about this. And so when we run back to our coherent science content storyline, clearly she had a goal in mind, not just the goal for that lesson, but the goal for the entire sequence. She has a question for each set of investigations that drive those, and she's carefully matched the activities not just to that lesson, but to the overall phenomena that kids are going to need to be able to explain. The content ideas are linked, and she's carefully sequenced, and this is what we mean by a storyline. And again, and I'm going to move through these two. These go back to what Mary was talking about, but it moves away from this starting with activities to using activities to sequence learning opportunities, and that's one of those big shifts that I talked about in the beginning that we're hoping to be able to make. And so the thing that I've added in here, this is the same sequence that I showed you previously, is the activities. So there's one more column that Kimber includes, and this is either the final consideration or it is at the very least considered in relation to these other components. So she still guides with the CER framework, and the investigations are used mainly to make sure that you can match the kinds of evidence that students will be collecting back to the claim that they're trying to make, and that they'll actually be able to answer the question with the evidence and the claim that they are working on in the activity. So again, the idea here is to shift the activity from the driver to the supporting role of providing evidence to actually be able to construct the explanations. And then here's that lesson that you saw and the things that came after it. And so with that, Kathy's going to talk to us about one more thing that is incredibly important, and I think a lot of you commented on it when talking about Kimber's teaching, is the opportunities for these discourse-rich interactions in the service of constructing explanations from evidence. Kathy?
Thanks, Carla. Yes, that video was so rich in discourse, an opportunity to use that discourse to build students' ideas. And I just want to spend, I forgot to move the slide, a minute or two thinking about, excuse me, why talk is so important. Well, talk really lets us see and hear what students are thinking. It provides an opportunity, as I mentioned before, I think, for students to build on each other's ideas. They have the chance to think about what somebody else says and decide in their own mind if they agree or disagree, and what is their evidence for that. So it also helps us apprentice students, I love that language, into the social and intellectual practices of science. It's just so very important. And a few things that I really noticed in the video were the use and the integration of writing within the talk. The students brought to the science talk to their notebooks, and they went back to their data, and it was almost like a scaffold for them to use those notebooks to be part of their thinking. So this slide comes from my favorite talk website in the whole world, and that's the Inquiry Project, where it has a document called the Talk Primer that is free, downloadable, that was built when they worked on this project, and there was also very good science there on the project. Again, from What's Your Evidence, here's the chart, and it talks about the different moves and some of the ways or things that teachers might say. One of the things that really stuck out to me when Kimber was talking was a student responded to a question, and she said, "So how did you know that?" Every question Kimber asked them dug just a little deeper into the content. She wanted those students to really think about and share their evidence and share their reasoning. And by having those opportunities for talk, they were able to do that. Children have to make meaning. It's not enough for us to just elicit the students' ideas and asking questions on their own. They can't be isolated activities. Those ideas that students started with must be leveraged, and we must provide learning opportunities so that those students will change their thinking. We not only want to change the thinking and reasoning of every student, but the class, we want the class as a whole to move forward. And sometimes when we're at this point and we're having children make meaning and we're listening to them talk, sometimes we might have to go back and think about what could we do differently, because they just may not have quite gotten it this time, and there might be something else that we as teachers need to do to help them make sense of that. Again, what I want you to do right now is to think about what are the connections to ELA or Common Core or mathematics. What connections did you see that came through in the video? Could you type in the chat here? We'd really be interested in seeing what you had to say here. Speaking and listening, writing in journals, oral communications, reading and writing, all the charts, measurement and data, tons of writing, expectations to justify, right, that reasoning piece. were so many opportunities in this lesson, and Kimber took advantage of all of those opportunities. And it didn't just happen by happenstance. They were intentionally thought about and crafted when she was planning her instruction. So I'm going to move on, and I'm going to show you a slide that many of you, I'm sure, have seen before. But I want you to really look just for a minute at all of the intersections and think about all of the places that math and ELA and science can integrate so naturally. And one of the things I keep thinking about a lot myself is when students are learning they need to read and write about something, our science content and concepts and practices could be that something. And we just have to think about it and make it explicit. You know, I think about people have told me that, you know, their administration won't allow them to teach science anymore because ELA and mathematics is so hard. I think we as educators have to show them where in our science that the math, the reading and writing is. So I just wanted to share this. I also want to say that I think that there's probably more connections than are right here in this slide. Again, we're really thinking about a new way of teaching, a new way of instruction. We're moving away from those single isolated activities to a coherent sequence of learning opportunities. And something that I learned just recently, and I've been thinking about a lot, is that coherence doesn't necessarily mean flow or sequence in our teacher, wearing our teacher hat. But when we're thinking about creating a coherent storyline, we need to think about what is coherence for the student? What do we need to do to provide a coherent flow for students to develop their learning? And there just is a distinction, and I just want us to think about that for a minute. Again, I'm going back to some of the resources that's really important for us to think about. The framework, we can't talk about more than enough. I could spend all day here. Here are some of the planning resources that are available. All of these are in the collection. These are some new ones that I've added into these collections that haven't been there before. There's a great chapter in teaching science with trade books. And here's another excellent resource, is Picture Perfect Science for integrating reading as part of the science. One of my favorite places to be. There are resources that are being added to this site all the time, so I want you to make sure to make time to go there. This is a duplicate, but one of the things that I want to point out is this book, Science and Literacy and Natural Fit. It's another excellent work in terms of thinking about student talk. There's a lot about student talk in that book. One of the things about, there's a website, Tools for Ambitious Science Teaching, and that really has some really good information about phenomena and building some storylines and some just a little bit different ways of saying some things. I talked before about the inquiry project. So this is Mary and my show here, a little bit here. Interested in continuing the conversations. Mary and I are going to start a Twitter chat very soon, August 20th to be exact, and that chat will be every other Thursday just before the regular NGSS chat, and we hope you'll join us. The hashtag is right here on the screen, and this is my thought right now. Why don't you take a minute, and if you have a topic or questions that you would like us to discuss, in these upcoming Twitter chats for elementary school educators around NGSS. Would you just put them there? Because they will help Mary and I get started, and we will know by doing that, we will be building on your ideas. So thank you, and please do that. And the other thing I'd like you to write in the chat before I finish is what is, again, one idea or approach that you're going to take away and help you do something just a little bit different in whatever your educational situation is. So we really appreciate you coming, and with that, I think I'm turning it back to Ted.
Thanks very much, Mary. Hey, Kathy, sorry. And thanks to all three of our wonderful presenters tonight. We'll do a chance to really applaud them in a little bit. I do want to first just give everyone here a chance to know where we can, other places we can continue our discussions or for more information. The nextgenscience.org website, the official site for the standards, is a very useful place to go, as is the NGSS at NSTA Hub. You can find that there, which we like to think is the source for all things NGSS. We've had a great discussion tonight. We hope to have some more on the Learning Center. There's a discussion forum specifically devoted to NGSS. And those of you who are NSTA members can also participate in a listserv devoted to NGSS. Please join that. We've had a great set of pieces so far this summer, but the fun never ends. We've got 2 more web seminars coming up, another one next Wednesday and then the following Wednesday with folks from Achieve providing information about the NGSS evidence statements and sample classroom assessment tasks. So I would encourage you to be there for that. If you like this web seminar, we've got tons more for you to check out. We've got over 40 different web seminars we've archived, one on each of the practices, each of the cross-cutting concepts, the disciplinary core ideas, assessment. We had these wonderful presenters, Kathy, Mary, and Carla, do a series on elementary this past year. We've also have great articles in all of our journals about NGSS, and this year we'll be having a series of articles devoted to NGSS running in all 3 journals. Books, and more books devoted to NGSS, Guide to the Framework, Guide to the Standards. I'm a little partial to the quick reference guides, but a variety of pieces for you that can help you in the work you're doing. We also we're really excited about our enhanced ebook, Discover the NGSS. For those of you who are familiar with the SciPACs NSTA has done, the Discover the NGSS is similar in some formats, although we've also designed it in a way that it works on tablets, iPads, Android tablets, laptops, you name it, we can do it. And it's about 40 hours of self-paced interactive learning, and is a really great introduction to NGSS. Finally, keep in mind that we've got area conferences this coming fall: Reno, Philadelphia, Kansas City. I hope to be I will be in all 3 of those locations doing some sessions on NGSS. There's lots of other sessions around the standards as well. Please come and seek us out if you happen to go there. And with that in mind, I will pass things off to Christina to help you get set for your evaluation. We will have some time for questions after you do your evaluation. But take a moment here to just thank tremendously Carla, Kathy, and Mary for the fantastic job they have been doing. They've done a series of 9 web seminars in the past year devoted to the elementary grades for NGSS. A little more than a year ago, I contacted Carla first, I think, and then she brought the others on to do this fabulous set for all of you. And so my great thanks to the 3 of them, the dynamic trio, I'll call them tonight. And so, Christina, if you want to take us onward, please.
Great. Yeah, I can see from the chat window, everyone has been extremely happy with the entire series. So I think everyone's a little bit sad that this is the last one in this series, but I'm sure it's not the last one forever. So really great job. I think everyone's going to really appreciate the archive as well. In addition to thanking our presenters, we'd also like to thank the Carnegie Corporation of New York, who sponsored today's web seminar. And in addition to our sponsors, to all the hardworking folks in the background at NSTA, with the Executive Director and Associate Executive Directors, as well as the web seminar team. Huge thanks for getting all these together, all scheduled, and a number of web seminars are already planned for this fall when the school year starts up. So huge amount of work done by everyone there. So with that, I'd like to thank you all for coming, and we hope to see you at a next NSTA web seminar. Thanks, everyone.